by, here's the moon illusion. Hopefully you got a chance to see it over the weekend. If you didn't, you'll have to wait a month to see another good full moon, but you'll see an illusion if you wait tonight. So the moon on the horizon versus the moon overhead. The first premise is S is equal to RD. The second is that the two retinal images are equal. You can check that by looking through a tube, measuring the retinal images, or taking a photograph. And those who take photographs of those big moons, you know how they get those great postcards of the big moon on the horizon? They cheat. There's one famous one of Golden Gate Bridge with a lot of sailboats on the bay, San Francisco, and a big giant moon hanging there over the horizon. What's wrong with it? Well, the first thing that's wrong with it is that means it's early in the morning because you're looking west at the Golden Gate, looking beyond, and the boats are out before dawn practically. So something's a little fishy because the boats really aren't out there, those sailboats. Then you look at the features on the moon and you realize they've cut out a picture of the moon taken over here and pasted it over there without correcting its position as to how it would be if it actually was over there. So you can create the postcard with Photoshop. You can also use a telephoto lens. That's another technique for getting those big postcards with the great moon. But if you just take a regular photograph, as you've discovered, it's pretty disappointing. So the retinal images are the same. The third premise is that the distance to the horizon is greater than the distance. Subjective distance looks like it's farther away, so it seems bigger. And that sounds backward to you because if the same object actually does go farther away, then its retinal image is smaller. But if the same retinal image is farther away, or looks farther away, then it looks bigger to correct for that fact. And that's what creates size constancy. So this equation, sometimes called Emmert's law when it applies to after images, it's also known as the size distance invariance hypothesis, which is the way you might find it in the psych journals. But it's also called the size constancy mechanism. So you've got to have an equation like that if you're going to satisfy a size constancy. Okay, how many got that for the moon illusion? Basically these three ideas. And I have S equals RD in there somewhere. How many? Let's see a couple. Okay, a few hands coming up. Not enough hands there. All right, so you got to work with that. That's also the explanation for the Ponzo illusion. So this one's Ponzo, 2 and 1. The argument here is these converging lines are a cue to distance. They're telling you that 2 is farther away. If this was actually railroad tracks, and you're standing on the railroad tracks, if you stand on this floor and look at these lines, you take a photograph of them, you'll see they're converging. So parallel lines are converging, giving you evidence of distance. And so this is farther away than this, and if this is farther away, the retinal images are the same, so you can measure the two. The retinal image is the same, S equals RD, D2 is greater than D1, and so S2 is equal to R2 D2, and R2 D2 we all know is greater than R1 D1, is equal to S1. All right, size constancy. Well, I don't know if I need to put the slide back up over there, but basically we're going to use the same ideas. We're going to have the guy in a normal room. So here's our normal room, and here's our person up close, and he walks twice as far away so that his retinal image is now half what it was. So if R2 is equal to 1/2 R1, but D2 is equal to, since he's gone twice as far away, so here he is at one distance, and now his retinal image, so R2 is half of R1, but if it looks like, here's D2, if D2 is twice D1, so in other words it's a normal room with nothing funny about distance, so if D2 is equal to 2 times D1, well, then S2 is going to be equal to R2 D2 is going to be equal to R1 D1 is going to be equal to S1. And so that's known as size constancy, because we're going to get R2 D2 is a half R1 times 2 D1, that's equal to R1 D1, because the half and the 2 are going to cancel out. All right, so it's going to come out even. So that's size constancy. So this equation is both size illusions and size constancies. All right, any questions about that? So that's size constancy. All right, what about the cues to distance or to depth? Yeah. We've got the binocular cues, our retinal disparity, otherwise known as stereopsis. We've got retinal, I guess I'll list it here, so retinal disparity. And what's the device that I told you could use and bring to the final exam? What are you allowed to bring? Thumbs. Yep, so you should know how to use your thumbs to examine a field for retinal disparity. Convergence angle, as seen from above, here's the two eyes. The eyes actually, to look at some object, have to bend inwards, and you can get an estimate from your brain is able to make a calculation of distance from how much tension is on the muscles to bring the two eyes at each other. Military planners already know how to build that kind of device, and by imitating nature you can create new inventions. The eye is like a camera. It's already a kind of theme. The eye is sort of like a camera. It has an image in it. It has a lens system. Uses refraction to create a lens image. The image is upside down and backwards. The lens, instead of being pushed forward and back to create focus, is actually changed in shape in the eye, so there's some differences with the eye. So those are binocular cues. And monocular cues, we've got motion parallax and accommodation. Motion parallax is the fact that by moving your head, you get information on depth. So right now I'm moving. This is what they will do if they want to create a 3D impression in a two-dimensional movie, not a 3D type movie, a stereo movie. But I want to create an image of depth. I'm going to move the camera, and all the objects are going to move relative to each other. That's called parallax. So if I only had one eye and I'm a pirate and I'm driving, I can move my head, and everything moves relative to everything else. As I move my head to the right, the things that are closest to me move to the left by the most. So as I move the head to the right, that's like switching from left eye to right eye. I can move my eye to the right. The thing that's in the right eye moves relatively to the left, right? So if I move the eye to the right, things move to the left. Things that are closest move the most relative to the other things. So that's another way to create depth. Accommodation is actually the focus of the lens. And so the brain is also able to calculate from the amount of tension on the muscle in the muscles that control the shape of the eye. And you're able to get an estimate of distance from that. And then there are the cues that the painters can use. So there's geometric perspective. For example, things like the lines that we had there, converging lines. Lines converge to a distance, give you a clue about distance. There's the height in the visual field. There's colors and clarity. The higher in the visual field it is, the farther away it is. Converging lines give you information about distance. So if you have converging lines and you assume they're parallel, they're closer together they are, the farther away they are. The higher something is in the visual field, the farther away it is. The bluer it is, or the more out of focus it is, the farther away it is. We've also got familiar size. So if you see Godzilla stepping on a car and you assume that the car is a full-size car, then you have an estimate of how far away Godzilla is and how big Godzilla is. And gradients and textures. Also overlaps. So here's the example of the that was illustrated in the textbook. This is one they're working on writing computer programs to try to do what the brain does. The brain analyzes things like this and assumes this surface is closer than that surface because it interprets a T-intersection. So basically a T-intersection, this thing is close, and these two are farther away, but it can't yet decide. It has to use other intersections in order to decide which things are closer. So all the objects you're looking at, some things are interrupting other objects, and a person can look at a scene like that and get the distance. How many got 5 of these? 4, at least. 3. All right, so you want to be able to say more. Any of these can be used to create illusions. So any of the cues can create illusions. And I described a number of the illusions you can create with them, including things that they do, like the backward face lit from below that you see at Disneyland in the Haunted Mansion, like 3D movies that you see over at Disneyland. A lot of things that are done in movies and in art are basically creating illusions. Anything you can do. Light and shade, I don't think I mentioned here. So yeah, I don't see light and shade on here. So light and shade. All right. That's the kid's the distance. Okay. Take a look. Let me see if I mentioned. Let me think about the homework and what's coming up here. So we're about ready to wrap up the course, and we're starting our reunion, seeing some folks I haven't seen for a while. We'll see the rest of them on Thursday, a week from Thursday. This Thursday, the research requirements are due. If you've already got your 5 credits in the SONA account and you don't have any negative credits outstanding against you, you don't need to do anything. You don't need to turn anything extra in. I will see a list of the people that have 5 or more credits. The people that went and did more, I saw there's some folks who did more than that who will be getting an extra credit. Yes, you need them 5 by Thursday. If not, then you have to read the syllabus and see what to do about that.
That's what I was going to say. After reading the syllabus, it said that if you do it a day later, you have to add
Then
another
you add,
credit.
then it's 6, and then if
And
you
then
do it
7.
by the final,
But would
it's
you
7.
still have full credit if you did 6 on the day late?
That's right. So
Okay.
everything is fine if you do that, but you don't want to have to do the extra. Yeah, but those who would rather do 7 can do it by the final exam, but then after the final exam, it becomes an incomplete. And then you have to do 7 to get rid of it, and you have to file paperwork and maybe pay a fine. I don't know. There's probably some fee for filing a petition to get rid of it. So you don't want to do that. So I recommend doing it by the deadline. It's important that you get your credit into your account on time. So some people say, I would like to sign up for an experiment and then do it by the deadline, but the person isn't going to give me credit on time. Is that okay? I'm going to print out the list and you'll be marked as late if it's not in your account. So don't sign up for something where the person isn't going to give you the credit. Online studies, I've warned you already. So those online studies that have a deadline of June 5th, they don't have to give the credit till June 7th. So I recommend don't sign up for those. You know, if you sign up for the June 5th and you do it tomorrow, the credit might not be there till June 7th. So Be warning, the online studies, you can do it on time, but you won't get the credit on time, so you need to have the credit in your account, basically. And you can write papers, you can read about that in the syllabus, so read the instructions for the papers, you get an article, you make a photocopy of the article, you type it up, you follow the various rules that are there, and turn those in on Thursday. So basically that's due. I saw there are a number of people really close to 5, but not quite there, so if you can't find a study to do, write one of the papers to top it off and get it to 5, because 4.5 does not round off to 5. 4.99 does not round off to 5. It has to be 5 or above to count as 5. All right. Do 34. View the Loftus video on false memories if you haven't done that already. Take the CALET multiple choice final exam. That's over on the left side, you'll find it. It's about 45 items. Print out and turn in page 1 only on Thursday. There's a number of other things under 35 that you don't have to turn in. These are things that are to help you. Study guides, what to study, review questions, other things just to help guide you, but they're not, there's a lot of things there that are not to be turned in necessarily. And there's a lot of other resources at CALET, other quizzes that you could take for other chapters, for example, that might be useful to you. Talking about Cinco de Mayo, it's a big holiday here in the United States. It's not as big a holiday in Mexico. Maybe in Pueblo it's a bit of a holiday. A lot of misinformation like Columbus Day. We have a holiday here called Columbus Day. People are confused about the story of Columbus. A lot of interesting history associated with Cinco de Mayo. You can find out why is it a big holiday in the U.S. What's it got to do with the Monroe Doctrine? How does it relate to the Emperor of Austro-Hungary, whose brother became Emperor of Mexico? And anyway, you can Mad Woman of Charlotte. A lot of other interesting connections through history, so you may want to use this opportunity to read up on the history of this holiday and understand what it's about. Big holiday in Mexico, of course, is my daughter's birthday, September 15th and 16th. That's Independence Day in Mexico.